diodes. Okay. Special diodes means it is application of diode. Okay. You already learned what is forward bias, what is reverse bias, all those stuffs for a diode. Okay. So it is an applications of diodes. The special diodes comes under the category of applications of diodes. Okay. In this, in your syllabus, we are going to learn 3 types of diodes. Okay. First one is photodiode. Okay, photodiode. The second one will be LED. That is nothing but light emitting diode. And the third one will be combination of these two, that is photodiode and LED, that is photocoupler. Okay, so that is combination, that is LED plus photodiode. Okay, these 3 things we are going to study under the category of special diodes. Okay, so first we'll start with the first one, that is photodiode. So if you see the construction of this photodiode, okay, it is so you know that PN junction, we have P layer and N layer. So this is P and this is N. So in between this region is called depletion region, that we have seen in when we are discussing in PN junction diodes. Okay, so this is depletion layer. Okay, now what they'll do is, upon this depletion layer, okay, they will make one window which is transparent. Okay, upon this depletion layer they'll make one transparent window, that is glass material, such that light is being made to fall on this window. Light is made to fall on this window. Okay, so that the light will fall on the depletion layer. So whenever photodiode comes into concept of discussion, what you have to do is, one should always remember that photodiode is always reverse biased. Okay, photodiode is always reverse biased. When I say reverse biased, so how do you connect reverse bias? You all learned this when we were discussing about forward bias and reverse bias of PN junctions, right? So if it has to be reverse biased, what kind of polarities that I have to give here? P type is connected to what? Which type of polarity? P type is connected to which type of polarity for reverse biasing? Yes.
Minus, sir.
Negative. Yes, negative. And N type is connected to positive polarity, right? So always remember, photodiode should be connected in reverse bias only. There is some reason for this. I'll let you know once I complete the complete operation of this diode. Okay, now what happens when a light is made to fall on this transparent window? What happens is, first thing is, okay, recombination of holes and electrons will take place. In the junction. Okay, so when the recombination of electrons and holes takes place, since it is reverse biased, minority charge carriers will start moving. Okay, minority charge carriers, because in reverse bias only minority charge carriers constitute for current flow. Okay, not majority charge carriers. Okay, that we have learnt in PN junction. Okay, now because of this minority charge carriers, what happens? Reverse current will start flowing in the circuit. Reverse current will start flowing. So this reverse current is directly proportional to the light induced on the depletion layer. If more light, more reverse current. If less light, less reverse current. Okay. The main application of this photodiode is it recognizes the light fall or intensity falling on the device. That's it. Okay. How much intensity? If more intensity, more current, more reverse current. If less intensity, less reverse current. If you see the characteristics of this, it looks like, okay, it looks like, okay, this is light intensity, that is luminous, and this is current I, that is reverse current. Okay, so it will be in microamps. Okay, reverse current means it will be in microamps. Always remember. Positive current means it will be in milliamps. Okay, negative current always it will be in microamps. It will be very less. Okay, so of a small change of luminous will give more reverse current. Okay, as the luminous increases, say for example 500, 1000, 1500, as the luminous or intensity increases, the reverse current also will start increasing gradually. Okay, so this is the characteristics of this special diode, this photodiode. Okay, and if you look at the symbol looks like this. Okay, put a circle for this normal diode. So it is emitting, light is falling onto the diode. That's why you will have a light falling onto the diode. So this is the symbol for photodiode. Okay, so what I mean to say is the basic concept of photodiode is, okay, the basic concept of photodiode is when light falls on the device, when light falls on the device, a reverse current will produce in the circuit. Okay, a reverse current will produce in the circuit. That is the main function of this photodiode. That means it detects the light falling on the device. Okay, so that current depends on the intensity of the light falling on the device. So if the intensity is more, the current, reverse current also will be more. If the intensity is less, the reverse current also will be less. The characteristics looks like this. If intensity is more, the current will also be more. Okay, so this is what all about photodiode. Any doubt in this photodiode? Shall we move on to next topic? Yes. Shall we move on to next topic after photodiode? Shall we move on to LED, because second part of special diode is LED. Okay. Yes. So first one is done. That is photodiode is done. Next will be LED. Yes. Any doubt in photodiode? Am I audible? Yes. Am I audible?
Yes, sir, audible.
So any doubt in photodiode?
No, sir, no, sir.
Okay. See why it is reverse biased. That's what I didn't tell you so far. Why it is reverse biased? Because even a small change in current, understand this, even a small change in current should be recognized. If you connect it as a forward biased, in case of forward biased, majority charge carriers constitute for current. If it is majority charge carriers, means it will be more in number. That's why current also will be large. It will be in millions. Yes, even a small change in that case, if it is forward biased, we can't recognize. Okay, recognize the small change in case of forward bias because majority charge carriers will be there in case of forward bias for the constitution of current. Whereas in case of reverse bias, minority charge carriers will be taking part to produce that reverse current. That minority charge carriers are in less number. Because these are in less number, even a small change in current we can notice. Okay, for that reason, the photodiode is always connected in reverse bias. Okay, if someone asks or somewhere if this question arises, you should be able to answer this. Okay, so this is all about photodiode, right? So next, we'll move on to LED. The next special diode is LED. LED. This is the second special diode. Full form is light emitting diode. So if you see light emitting diode, probably in real time you have seen, many of you would have seen what is LED. You would have touched it or you would have felt it, right? So the main concept in LED is, okay, the main difference between LED and photodiode is photodiode will absorb the light and produces the current, whereas LED will emit the light. Just opposite of that. Okay, just opposite of that. So if I want to write the circuit of that, okay, so just I'll show here, right? You can see here, right? This is the construction. There are two types of construction. This is cup type and this is normal construction. So if you see the construction, here also there is P and N type semiconductors. Okay, that means this is also the applications diode and it is a special diode. Can you see here? You have P type semiconductor, right? And you have N type semiconductor. So the top layer is P type, this one, and this is P type and this is N type. In between P type and N type there will be active region. Okay, active region is nothing but depletion region. Okay, so and the down plate is called as substrate. Okay, it is substrate. Substrate means it is a base. Okay, so what happens is the main working principle of this LED is energy band. Okay, if you know the energy band functionalities, probably it will be easy for you to understand the functioning of LED. So if you see the energy bands, how it functions, okay, say this is conduction band and below conduction band there will be valence band. Okay, so this is valence band, okay, and this is conduction band. Okay, so this is the difference between valence band and conduction band. Okay, this is energy gap between conduction band and valence band. Now we know that in conduction band free electrons will be available. Okay, we know that in conduction band free electrons will be available. In case of valence band you have holes. Okay, you have holes. Okay, in valence band you have holes. So what happens is when I forward bias this P and N junction, P and N junction, N type semiconductor, if I forward this, what happens? The electrons in the conduction band will jump to valence band by releasing some energy. Okay, the electrons from conduction band will jump to valence band by releasing some energy in the form of light. Okay, in the form of light. That means from higher energy level to lower energy level, the electron is falling. So when it falls from higher energy level to lower energy level, it emits the energy in the form of light. So that's what it happens in case of LED. That's why the light is blown. Okay, the now I have one more diagram that will clearly make you understand. So this is what it is. You have conduction band, okay, and you have valence band. In conduction band you have free electrons, and in valence band you have holes, okay. So whenever it is PN junction is forward biased, what happens? The electrons from the conduction band will fall to valence band. That means it falls from higher band to lower band. When it falls from higher band to lower band, the energy is been released in the form of light. So that's what it is. When the electron falls from higher energy level to lower energy level, the energy will be released in the form of light. Okay, this is what the main concept in case of LED. So always remember, LED can be constructed like this. Okay, you can see here the construction of LED. Okay, it is always forward biased. Can you see the P type semiconductor is connected to positive terminal and N type semiconductor is connected to negative terminal. Okay, so when it is forward biased, the recombination of electron holes takes place. During the recombination, the electrons from the upper energy level, that is conduction band, will fall to valence band by releasing the light. Okay, this is called as LED. And one more thing that you need to make understand is there are different colors in case of LED, correct? There are different colors that are available in LED. How are these colors are formed? How are these colors are formed? Okay, that you need to understand. Okay, uh, okay. So if you see the energy bands of each color, okay, the you have different colors for different energy levels. Just I'll just give one or two examples of that. Okay, uh, 1 second. I'm just looking at some document where I can find different colors for that. Okay, LED energy, uh, energy. Okay, okay. 1 second. I'm just looking at some references so that yes. See, if the energy level, this forbidden gap is there, no? If this energy level is of say one, if it is less than 1.6 electron volt, if it is less than 1.63 electron volt, this will be infrared. Okay, IR light, okay, which is used in remotes. Okay, next, if the energy level is from 1.63 to 2.03 electron volt, then this is red. You will get red light out of this gap. Okay, next, if energy levels, this is just for your understanding, it is not required for the syllabus writing. Okay, it is just for your understanding. Okay, next, if the energy band, if the energy is 2.2 2.1 electron volt to, okay, 2.18 electron volt, then the light will be of yellow, no, not yellow, orange. Okay, next 2.18, 2.8, sorry, 2.18 to 2.48, it will be green. So the light color depends on this energy gap. Okay, so for different energy gap, different lights will be emitted, different colors will be emitted. That's what I told here. So this is all about LED. Okay, and now the symbol looks something like this. So you have a diode. Okay, this is the diode. Put a circle as usual. In case of photodiode, the light was falling, correct? But in case of LED, it should be emitting. So it will be emitting, going outside. Okay. So this is the symbol for LED. Okay. So this is all about LED. Next, you understood what is photodiode and you have understood what is LED. Now we will see what is photocoupler. Okay. Photocoupler is, so this is the circuit for photocoupler. You can notice that photocoupler is the combination of both LED and photodiode. So this is the right side. The right side one is photodiode. Okay, you can notice, and the left side one is LED. If you understand, it will be very easy. Okay, so this is photodiode. You can see that. What is the symbol of photodiode? It looks like this, and out of this, the light is falling on this. Can you see? The light is falling on this. Okay, how does LED look? It is again similar. Put circle, and light is going away from this diode, correct? That's what light is going away from this diode. Okay, this is LED. So it is a combination of LED and photodiode is nothing but photocoupler. Okay, so light emits from the LED and light will be detected from the photodiode. Okay, these two combinations will give rise to a new device called photocoupler. Okay, now where do we use this circuit or this device? Say for example, if you want the number of persons getting into the classroom, okay, if you want to count the number of persons entering into the classroom, what we'll do is, okay, see here, if this is the door, okay, if this is the door of the classroom, what I'll do is I'll fix to one end the LED. So this is LED, and to the other end I'll fix photodiode, and this circuit is made on. Once the circuit is made on, this LED continuously it will emit light, right? It will continuously emit the light, and this photodiode will continuously detect the light which is emitted by this LED. Okay, there is continuity. Now, say any one person enters into the class. So now one person is entering into the class. What happens? There is a break of light that is moving from, that is emitted from LED to the photodetector. What happens? There is a break. If there is a break, what happens? The circuit which is connected to the photodiode, the current will be breaking off. There won't be any current in the photodiode. That's what we have learned here, isn't it? See, in photodiode, if there is no light falling on the photodiode, what happens? There won't be any current. So that means current is broken, means it is disconnected. So the number of times that current is disconnected gives number of persons entered the class. Okay, number of times the current is disconnected from LED to photodetector gives the number of persons entered the class. Okay, so this photodetector is connected in fact to a counter. That counter will give the number of counts like how many times the current has been disconnected. So that gives the number of count. So this is just an application of photo detector, right? So that's what I wanted to tell here. So photo detector is the combination of LED, which will always continuously emit the light, and photo detector, which always observes the light or detects the light. Okay. So this is all about photo coupler. Okay. Next, photocoupler is also called as optocoupler. Okay, don't get confused. Sometimes if they ask optocoupler, you don't think that what is this optocoupler. Okay, it is nothing but photocoupler. Opto means photo. Okay, right. Next, we'll move on to timer, IC voltage regulator. Okay, IC means what? Integrated circuit. Generally, this ICs will be there will be an internal circuit in that which you can't be seen. So it will be sealed completely, and only leads like 4 leads or 8 leads or 16 leads will be going taken out of that. Okay, so that is nothing but IC. Many of you would have seen this. Okay, ICs. So if you just put one IC, you can get that. First of all, you should know what is regulation. Yes, anybody can you define what is regulation or regulator? What is regulator? Can anyone define what is regulator? Do you have any idea about regulator? Right. No issues. So regulator means, say for example, you have a charger, phone charger with you. Everyone has that. So what is the input to the charger? That is AC mains. So input to the charger will be 120, 220, 230 volts to it varies up to 400 volts. Okay, this is the input to the charger, right? So this input is given to an IC, this IC, okay, and then out of this, what happens? You will get one output which is fixed, that is 12 volts. So your output of regulator is 12 volts, right? So what does this mean? Which is the device that you are using? That is nothing but a regulator. So, okay, your regulator does a job of giving a constant output for a variable input voltage. You have a variable input voltage which is varying from 230 volts to 400 volts. Okay, but the output remains constant at 12 volts. This is called regulator or regulation. Okay, so the device which is doing that is IC. Which is that IC? There are two types of ICs. There are two series of that ICs. One is 78XX and 79XX. What is this 78 and 79 refers to? 78 refers to a positive and 79 refers to a negative. Means positive voltage regulator and negative voltage regulator. What is this 78 double X? What is this double X means? Say for example 7812. What does this mean? 78 is positive. This 12 represents 12 volts output, fixed output. Okay, so if it is 7806, what does this mean? Positive 6 volts output. Okay, next if it is 79XX, what does this mean? So 7N is negative output. So if I say that 5912, what does this mean? Negative 12 volts output. And if it is 7909, what does this mean? Negative 9 volts output. So generally if you see the IC, it has 3 terminals. This is what it looks like. It has 3 terminals. Which are those terminals? We should have input, variable input, and we should have one output, and there should be obviously one ground. Okay, that's what it is. So you can write this something like this also. There is no any issues. Connect all these 3 and write one common ground. So there are 3 terminals: input, variable input, fixed output, and common ground. So this is nothing but IC. Okay, so that is what they have told in all these things. So now you can see here Okay, if you see this circuit, okay, connection, they have used 7812. Can you see here? They have used 7812 IC. What does this mean? It is positive. 78 refers to positive. That's why the output is positive. How much volt output? It is 12 volts. That's why output positive 12 volts output is there. Instead of this 7812, if they have used 7912, how does the output look? How does the output look?
Negative 12 volt.
Yes, yes, negative 12 volts. So this is negative 12 volts. Good. So this is all about IC voltage regulator. Okay. And the output is given by this formula. That is 1 plus R2 dash divided by R1 dash. Where is this R1 and R2? There is one more circuit which is there here. Can you see here? This is the functional block diagram of 3-terminal IC regulator. Probably, if I tell about this circuit for you, it will be a bit strange because we have not yet studied the operational amplifiers. This diagram, you can see here one triangular part. Okay, this is nothing but op amp, which we are going to study in the module 3. Okay, in module 3, this operational amplifiers we are going to study. Okay, this operational amplifier has two inputs. Okay, one is inverting terminal and non-inverting terminal. Okay, the plus symbol refers for non-inverting terminal and negative symbol refers for inverting terminal. So you will get one feedback input to the inverting terminal, and non-inverting terminal is reference voltage. Say for example, if you want reference voltage as 12 volts, you keep reference voltage as 12 volts, the output also will be fixing at 12 volts. Okay, so depending on this feedback is coming from this. Okay, then it will map, it will find out whether this feedback is equal to this 12 volts. If it is not equal, again you adjust it until it is becoming 12 volts at the this output should be 0. That's it. If there is any difference of this two, then it keeps on increasing and decreasing such that the difference becomes 0. Means if difference becomes 0, that means this and this should be equal. 12 minus 12 will be 0. Okay, 12 minus 12 will be 0, right? So once it is 0, that means the output will be fixed at 12 volts. Say if it is 15 volts and I want 12 volts as an output, then what happens? Here it comes 15 because the same line is connected here. Okay, 15 minus 12 is how much it will be? There will be some difference called minus 3 volts. So it is not same. So that's why again some adjustment will happen at this point. Again a small decrease of voltage will happen until we will get 12 volts at the output. So this is all about functional block diagram of 3-terminal IC regulator. Anyhow, this diagram we are going to study in detail probably in module 4. In detail we are going to study again in module 4. So that's why I am not concentrating much on this functional block diagram right now. You won't understand also. Okay. For that reason, just a hint I have given. This is how the adjustment is done upon feedback system. Okay. Into the operational amplifier. Okay. So this is all about today's class. Okay. So we have studied photodiode, we have studied LED, and we have studied photocoupler, which is combination of LED and photodiode, and then we have studied IC voltage regulator. Okay, so by this we have completed module 1. Probably for your internal point of view, you study whatever we are doing for this. If you have any doubt, please ask from these topics right now. Okay.